Okay, this one's a doozy. And blah, 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 blah. Here is our equation. We are modelling theta, where it's a trigonometric function. We're going to be working in radians. Make sure your class pad is in radians. So we know that when n equals 26, theta equals 71.4. We want to calculate for 10 days earlier. So when n equals 16, theta will equal 23.5 times sine of 2 pi 101 plus 16 all over 1, 4. So that's 8 pi. 1461 plus 52.2. Be careful putting this into your calculator. Make sure you're in radians. So when I get that out of my calculator, they've used one decimal place here, so I'm going to use one decimal place. So they've got 73.44, so we leave it as that. So that's the degrees. Now, even this is finding degrees. This is in radians when we do the calculations. A bit confusing. Graph the altitude below. Okay, so I'm going to go back and I'm going to put in a few values. I'm going to put in n equals 0. So change the 16 to 0 and I get 75, just over 75. And I'm going to put in, we're going out to 365. So change 0 to 365 and I get 75. So it's going to do, it's a sine function. It's been translated so it's and lifted. So let's have a look. And we know that for 16, oh, that's no use to me. Let's have a quick graph of it and see if we can find some minimum point. Okay, so I've sketched this on my class pad. And when I find the minimum, it is on day 172 and it's at 28.5. So that's in here somewhere, there's a minimum. And when we can't do, no, they don't do points of inflection. So it's going to come down like that, and it's going to go like that, back. And now I need to get my ruler, and it's 36 degrees, so it's 35, so it's just above that. Use another pen. It's just these days here where it doesn't meet it. So that's about 125-ish. Now, my graph isn't accurate